When it comes to data sourcing, obviously the most important thing is to get data, but the easiest way to do that, at least in theory, is to use existing data. Think of it as going to the bookshelf and getting the data that you have right there at hand. Now, there's a few different ways to do this. You can get in-house data, you can get open data, and you can get third-party data. Another nice way to think of that is proprietary, public, and purchased data, the 3 Ps I've heard it called. Let's talk about each of these a little bit more. So in-house data, that's stuff that's already in your organization. What's nice about that is it can be really fast and easy. It's right there. And the format may be appropriate for the kind of software and the computer that you're using. If you're fortunate, there's good documentation, although sometimes when it's in-house, people just kind of throw it together. So you have to watch out for that. And there's the issue of quality control. Now, this is true with any kind of data, but you need to pay attention with in-house because you don't know the circumstances necessarily under which people gathered the data and how much attention they were paying to something. There's also an issue of restrictions. There may be some data that while it's in-house, you may not be allowed to use, or you may not be able to publish the results or share the results with other people. So these are things that you need to think about when you're going to use in-house data in terms of how can you use it to facilitate your data science projects. Specifically, there are a few pros and cons. In-house data, potentially quick, easy, free. Hopefully it's standardized. Maybe even the original team that conducted this study is still there. And you might have identifiers in the data which make it easier for you to do an individual level analysis. On the con side, however, the in-house data simply may not exist. Maybe it's just not there. Or the documentation may be inadequate. And of course, the quality may be uncertain. It's always true, but maybe something you have to pay more attention to when you're using in-house data. Now, another choice is open data, like going to the library and getting something. This is prepared data that's freely available. It consists of things like government data and corporate data and scientific data from a number of sources. Let me show you some of my favorite open data sources, just so you know where they are and that they exist. Probably the best one is data.gov here in the US. That is it says right here, the home of the US government's open data. Or you may have a state level one. For instance, I'm in Utah and we have data.utah.gov, also a great source of more regional information. If you're in Europe, you have open-data.europa.eu, the European Union Open Data Portal. And then there are major nonprofit organizations. So the UN has unicef.org/statistics for their statistical and monitoring data. The World Health Organization has the Global Health Observatory at who.int/GHO. And then there are private organizations that work in the public interest, such as the Pew Research Center, which shares a lot of its data sets, and the New York Times, which makes it possible to use APIs to access a huge amount of the data of things they've published over a huge time span. And then two of the mother loads, there's Google, which at google.com has public data, which is a wonderful thing. And then Amazon at aws.amazon.com datasets has gargantuan datasets. So if you needed a dataset that was like 5 terabytes in size, this is the place that you would go to get it. Now, there's some pros and cons to using this kind of open data. First is that you can get very valuable datasets that maybe cost millions of dollars to gather and to process. And you can get a very wide range of topics and times and groups of people and so on. And often the data is very well formatted and well documented. There are, however, a few cons. Sometimes there's biased samples. Say, for instance, you only get people who have internet access, and that can mean, not everybody. Sometimes the meaning of the data is not clear, or it may not mean exactly what you want it to. A potential problem is that sometimes you may need to share your analyses. And if you're doing proprietary research, well, it's going to have to be open research instead. And so that can create a crimp with some of your clients. And then finally, there are issues with privacy and confidentiality. And in public data, that usually means that the identifiers are not there, and you're going to have to work at a larger aggregate level of measurement. Another option is to use data from a third party. These go by the name Data as a Service, or DaaS. You can also call them data brokers. And the thing about data brokers is they can give you an enormous amount of data on many different topics. Plus, they can save you some time and effort by actually doing some of the processing for you. And that can include things like consumer behaviors and preferences. They can get contact information. They can do marketing, identity, and finances. There's a lot of things. There's a number of data brokers around. Here's a few of them. Acxiom is probably the biggest one in terms of marketing data. There's also Nielsen, which provides data primarily for media consumption. And there's another organization, DataSift. That's a smaller, newer one. And there's a pretty wide range of choices, but these are some of the big ones. Now, the thing about using data brokers, there's some pros and there's some cons. The pros are, first, that it can save you a lot of time and effort. It can also give you individual level data, which can be hard to get from open data. Open data is usually at the community level. They can give you information about specific consumers. They can even give you summaries and inferences about things like credit scores and marital status, possibly even whether a person gambles or smokes. Now, the con is this. Number one, it can be really expensive. I mean, this is a huge service. It provides a lot of benefit and is priced accordingly. Also, you still need to validate it. You still need to double check that it means what you think it means and that it works in with what you want. And probably a real sticking point here is the use of third-party data is distasteful to many people. And so you have to be aware of that as you're making your choices. So in sum, as far as data sourcing existing data goes, obviously data science needs data. And there's the 3 Ps of data sources: proprietary and public and purchased. But no matter what source you use, you need to pay attention to quality and to the meaning and the usability of the data to help you along in your own projects. When it comes to data sourcing, a really good way of getting data is to use what are called APIs. Now, I like to think of these as the digital version of Prufrock's Mermaids, if you're familiar with the love song of J. Alfred Prufrock by T.S. Eliot. He says, "I have heard the mermaids singing each to each." That's T.S. Eliot. And I like to adapt that to say, APIs have heard apps singing each to each. And that's by me. Now, more specifically, when we talk about an API, what we're talking about is something called an application programming interface. And this is something that allows programs to talk to each other. Its most important use in terms of data science is it allows you to get web data. It allows your program to directly go to the web on its own, grab the data, bring it back in, almost as though it were local data. And that's a really wonderful thing. Now, the most common version of APIs for data science are called REST APIs. That stands for Representational State Transfer. That's the software architectural style of the World Wide Web. And it allows you to access data on web pages via HTTP. That's the Hypertext Transfer Protocol that runs the web as we know it. And when you download the data, you usually get it in JSON format. That stands for JavaScript Object Notation. The nice thing about that is that's human readable, but it's even better for machines. Then you can take that information and you can send it directly to other programs. And the nice thing about REST APIs is that they're what's called language agnostic, meaning any programming language can call a REST API, can get data from the web, and can do whatever it needs to with it. Now, there are a few kinds of APIs that are really common. The first is what are called social APIs. These are ways of interfacing with social networks. So for instance, the most common is Facebook. There's also Twitter. Google Talk has been a big one, and Foursquare as well, and then SoundCloud. These are on lists of the most popular ones. And then there are also what are called visual APIs, which are for getting visual data. So for instance, Google Maps is the most common, but YouTube, something that accesses YouTube on a particular website, or AccuWeather, which is for getting weather information, Pinterest for photos, and Flickr for photos as well. So these are some really common APIs, and you can program your computer to pull in data from any of these services and sites and integrate it into your own website or here into your own data analysis. Now, there's a few different ways you can do this. You can program it in R, the statistical programming language. You can do it in Python. Also, you can even do it in the very basic Bash command line interface. And there's a ton of other applications. Basically, anything can access an API one way or another. Now, I'd like to show you how this works in R. So I'm going to open up a script in RStudio, and then I'm going to use it to get some very basic information from a web page. Let me go to RStudio and show you how this works. I've opened up a script in RStudio that allows me to do some data sourcing here. Now, I'm just going to use a package called JSON-Lite. I'm going to load that one up. And then I'm going to go to a couple of websites. I'm going to be getting historical data from Formula One car races, and I'm going to be getting it from airgas.com. Now, if we go to this page right here, I can just go straight to my browser right now. And this is what it looks like. It gives you the API documentation. So what you're doing for an API is you're just entering a web address, and in that web address, it includes the information that you want. I'll go back to R here for a second. And if I want to get information about 1957 races in JSON format, I go to this address, and I can skip over to that for a second. And what you see is it's kind of a big long mess here, but it is all labeled and it's clear to the computer what's going on here. I'll go back to R. And so what I'm going to do is I'm going to save that URL into an object here in R. And then I'm going to use the command from JSON to read that URL and save it into R, and which it is now done. And I'm going to zoom in on that so you can see what's happened. I've got this sort of mess of text. This is actually a list object in R. And then I'm going to get just the structure of that object. So I'm going to do this one right here. And you can see that it's a list, and it gives you the names of all the variables within each one of the lists. And what I'm going to do is I'm going to convert that list to a data frame I went through the list and found exactly where the information I wanted was located. You have to use this big, long statement here. That'll give me the names of the drivers. Let me zoom in on that again. There they are. And then I'm going to get just the column names for that bit of the data frame. And so what I have here is 6 different variables. And then what I'm going to do is I'm going to pick just the first 5 cases, and I'm going to select some variables and put them in a different order. And when I do that, this is what I get. I'll zoom in on that again. And the first 5 people listed in this data set that I pulled in from 1957 are Juan Fangio, makes sense, one of the greatest drivers ever, and other people who competed in that year. And so what I've done is by using this API call in R, it's a very simple thing to do, I was able to pull data off that web page in a structured format and do a very simple analysis with it. And let's sum up what we've learned from all of this. First off, APIs make it really easy to work with web data. They structure it, they call it for you, and then they feed it straight into the programs for you to analyze. And they're one of the best ways of getting data and getting started in data science. When you're looking for data, another great way of getting data is through scraping. And what that means is pulling information from web pages. I like to think of it as when data is hiding in the open. It's there, you can see it, but there's not an easy, immediate way to get that data. Now, when you're dealing with scraping, you can get data in several different formats. You can get HTML text from web pages. You can get HTML tables, the rows and columns that appear on web pages. You can scrape data from PDFs, and you can scrape data from all sorts of media like images and video and audio. Now, we'll make one very important qualification before we say anything else. Pay attention to copyright and privacy. Just because something is on the web doesn't mean you're allowed to pull it out. Information gets copyrighted. And so when I use examples here, I make sure that this is stuff that's publicly available, and you should do the same when you're doing your own analyses. Now, if you want to scrape data, there's a couple of ways to do it. Number one is to use apps that are developed for this. So for instance, import.io is one of my favorites. It's both a web page, that's its address, and it's a downloadable app. There's also ScraperWiki. There's an application called Tabula, and you can even do scraping in Google Sheets, which I'll demonstrate in a second, and Excel. Or if you don't want to use an app, or if you want to do something that apps don't really let you do, you can code your scraper. You can do it directly in R or Python or Bash or even Java or PHP. Now, what you're going to do is you're going to be looking for information on the web page. If you're looking for HTML text, what you're going to do is you're going to pull structured text from web pages, similar to how a reader view works in a browser. It uses HTML tags on the web page to identify what's the important information. So that's things like body and H1 for header 1 and P for paragraph in the angle brackets. You can also get information from HTML tables, although this is a physical table of rows and columns I'm showing you. This also uses HTML table tags. That's like table and TR for table row and TD for table data. That's a cell. The trick is when you're doing this, you need the table number, and sometimes you just have to find that through trial and error. Let me give you an example of how this works. Let's take a look at this Wikipedia page on the Iron Chef America competition. I'm going to go to the web right now and show you that one. So here we are in Wikipedia, Iron Chef America. And if you scroll down a little bit, you see we got a whole bunch of text here, and we got our table of contents. And then we come down here, we have a table that lists the winners, the statistics for the winners. And let's say we want to pull that from this web page into another program for us to analyze. Well, there's an extremely easy way to do this with Google Sheets. All we need to do is open up a Google Sheet, and in cell A1 of that Google Sheet, we paste in this formula. It's import HTML, then you give the web page, then you say that you're importing a table. You have to put that stuff in quotes, and the index number for the table. I had to poke around a little bit to figure out that this one was table number 2. So let me go to Google Sheets and show you how this works. Here I have a Google Sheet, and right now it's got nothing in it, but watch this. If I come here to this cell and I simply paste in that information, all this stuff just sort of magically propagates into the sheet, makes it extremely easy to deal with. And now I can, for instance, save this as a CSV file, put it in another program, lots of options. And so this is one way that I'm scraping the data from a web page because I didn't use an API, but I just use a very simple one-line command in Google Sheets to get the information. Now that was an HTML table. You can also scrape data from PDFs. You have to be aware of whether it's a native PDF, I call that a text PDF, or a scanned or image PDF. And what it does with native PDFs is it looks for text elements. Again, those are like code that indicates this is text. And you can deal with raster images, that's pixel images, or vector, which draws the lines, and that's what makes them infinitely scalable in many situations. And then in PDFs, you can deal with tabular data, but you probably have to use a specialized program like Scraper, Wiki, or Tabula in order to get that. And then finally, media like images and video and audio. Getting images is easy. You can download them in a lot of different ways. And then if you want to read data from them, say for instance, you have a heat map of a country, you can go through it, but you'll probably have to write a program that loops through the image pixel by pixel to read the data and then encode it numerically into your statistical program. Now that's my very brief summary, and let's summarize that. First off, if the data you're trying to get at doesn't have an existing API, you can try scraping. And you can use specialized apps for scraping, or you can write code in a language like R or Python. But no matter what you do, be sensitive to issues of copyright and privacy so you don't get yourself in hot water, but instead you make an analysis that can be of great use to you or to your client.